Welcome to the Wolfram Language in Section 4 of Fast Introduction for Programmers. This section is about a basic principle of the Wolfram Language, which is that everything in the language is a symbolic expression. For example, numbers, and strings, and images, and formulas are all symbolic expressions. Even the notebook document that is being displayed in this video is a symbolic expression. All symbolic expressions have the same basic structure of a head followed by arguments. So here, for example, is a generic symbolic expression with head f and arguments x and y. Many of the most common symbolic expressions have special forms for input and for display, like lists, for example, are typically entered using curly braces. These are just different ways of entering and displaying the same expression. Sums are typically shown with a plus sign rather than by entering the head of plus and square brackets around the arguments. Again, these are just different ways of showing the same expression. The earlier example of an image of a sphere is another symbolic expression. The image of a sphere is the displayed form of a symbolic expression with a head of graphics 3D and with sphere as the argument. The arguments of a symbolic expression can be other symbolic expressions, and this graphics 3D input is an example of that. That image can itself be used as an argument. So, for example, this shows a symbolic expression with a head of edge detect and with that graphics 3D expression as the argument. The Wolfram language is fully symbolic, so undefined variables like x can just stand for themselves. And the symbolic expression with head f and with x and y as arguments can represent the mathematical function f of xy or whatever else you want it to be. There is a function called full form that you can use if you want to see the structure of an expression without special displayed forms like plus signs and curly braces. For example, this uses the full form function to show the structure of a symbolic formula. And this uses the full form function to show the structure of a nested list. Nested lists like this are used in the Wolfram language to represent arrays. You can use the head function to show just the head of an expression. For example, the head of f of xy is f. And the head of a list is the symbol list. And the head of a sum is plus. You can use the length function to get the number of arguments in a symbolic expression. For example, this uses the length function to count the number of elements in a list. That's the end of the examples for this section. You can find more information about expressions by choosing Wolfram Documentation under the Help menu to bring up the Documentation Center page, clicking the Core Language and Structure button, and then choosing Expressions under the menu that comes up, which brings up this page with links to information about functions for modifying expressions and displaying expressions and so on. The notion that everything in the Wolfram language uses this same unifying structure of a symbolic expression can often be very helpful in gaining a deeper understanding of the language.